All right, guys, welcome to your review video for test 4. Hope it helps. Let's get this thing going here. Number 1 is asking for the vertex, axis symmetry, and y-intercept of one that's already in vertex form. Because it's in vertex form, remember the vertex is the opposite of what's in the middle. In the parentheses and exactly what's outside. The axis symmetry, do not forget to put your x equals your x coordinate there. The y-intercept, we're going to find by plugging a 0 in for x right there. And if I plug in a 0 in for x and just work that out, I get negative 3 squared, which is 9, times 2 is 18, plus 1 is 19. That's a big y-intercept, way up at 19. So graph it here. Vertex is 3, 1. Because there's a 2 in the front, I'm going to go over 1, up 2, over 1, up 2. Connect the dots. And there's your graph, just like that. Number 2, you need to find the vertex. So what we need to do in number 2, because it's in standard form, is go to negative b over 2a. So negative b would be 12. A is negative 2. That gives me 12 over negative 4, which is negative 3. So my vertex is going to be negative 3 something. Also, that tells me my axis is going to be negative 3. X equals negative 3. To find the y part of the vertex, I've got to plug the negative 3 in for x. You can do this on your calculator if you would like. Let's see, 9, so that's going to be 18 plus 36 minus 3. That's huge. That's going to be 51. So the vertex, that's crazy. Let me look at that real quick. All right, looks right. So bottom line is that vertex, negative 3, 51 is like way up here. I'm just going to put a point like way up there somewhere. It should be way up. The one on your test will work out much better. Because there's a negative 2 in the front, we're going to go over 1, down 2, over 1, down 2, connect the dots like that. Now, the good thing about this one is the y-intercept, when it's in standard form, is just that last number. It's also negative 3, lots of negative 3s. Because if I were to put 0 in for x up there, the only term that would be left is a negative 3. So that's why the y-intercept is negative 3. All right, number 3 and 4, solve using your calculator by graphing. Number 3 is already set up for you. I'm going to go to y equals. I'm doing that as I speak to you. I'm punching in negative 2x plus 3. Go to y2, punch in 2x minus 1. I'm going I'm going zoom 6 to graph it. Zoom 6 to graph it. I'm looking for the intersection point, which I see. So I'm going to go second calc, 5, enter. And it's looking like it is 1, 1. So all you have to put on your paper here is 1, 1, which is pretty good. The second one right here, number 4, you can't plug it in your calculator to get y by itself. So first thing I'm doing on the top equation is I'm going to move that 3x over like that. Then I'm going to divide the whole side by 3. Now, because they're all 3s, if you wanted to, you could actually cancel out those 3s. But I'm going to plug that into y1. And by the way, that numerator's got to be in parentheses because there's 2 things. The second equation, I'm going to do the same thing. I'm going to move the 4x over like that, divide by 3, and I get negative 4x plus 6 over 3. I'm going to do the same thing I did on number 3. I'm going to plug those in my calc. And again, that equation have 2 numbers in my numerator, so you must use parentheses. Or, of course, you can use your fraction bar. Okay, zoom 6 to graph, second calc 5, enter. I'm getting 3, negative 2 for that answer. That's all you got to do there. Okay, so a little bit of work on 4, but let your calculator do the work for you. Number 5 says you must show elimination to get full credit. So what I'm going to do on number 5, let me change colors here. I'm going to, let's see here, I'm going to make the y's go away. So I'm going to multiply the top equation by negative 3, because when I do that, I get negative 9x, of course. But I get positive 3y, which is what I wanted. And I can just bring this equation straight over. And if you look at why I did that, the reason is because my y's are going to cancel, like boom. That gives me negative 8x over here. Over here I get negative 16, so x is 2. I got to find the y, though, because my answer is going to be 2 something. So I'm going to plug the 2. It doesn't matter. I'm going to plug it right there. It looks pretty simple. Plug the 2 in for that x, minus 3y is 5. Let's move that 2 over. If I move that 2 over there, it becomes 3. So if I divide by negative 3, y is negative 1. So there's number 5. Number 6, I'm going to do the same kind of steps here. I'm going to multiply the top one this time by negative 2 to try to make to be honest, either one of them is going to go away. So if I multiply by negative 2, that's I'm trying to make my x's eliminate. So I'm going to do negative 6x plus 4y. Don't forget the other side, negative 20. Here, I already have negative 6 plus 4y equals, I'm glad I did this. I messed up right there. I'm glad that you saw me do this. I should not have multiplied by -2. I should multiply by +2 because I always want the signs here to be opposite, and they're already opposite. So I'm going to change my signs, make that a positive, make that a negative, make that a positive, because that's what I should have done. Sorry about that, but I'm kind of glad you saw that. So that everything cancels, and if everything cancels, I get 0 equals 0. Now you got to ask yourself, is that true? And your answer should be yes, that's true. 0 does equal 0. That means there are infinite solutions. That's all that means. There are infinite solutions. Don't put all reals, infinite solutions. Number 7 says solve by substitution. I'm going to show you your work. Remember substitution, we're looking for an x or a y that has a 1. So it's right there. And this one's ready to go. I already know what x equals. X is 2y minus 10. So I'm going to put that 2y minus 10 into the other x. So I'm going to say 4 times instead of x, 2y minus 10 plus 2y equals 10. Let's distribute here. 8y minus 40 plus 2y is 10. That gives me 10y, minus 40 is 10. Move that 40 over. It becomes plus 40, which makes that 50. Divide by 10. Got y is 5. There's my y. Now, the good thing about substitution is you just plug it right back where we started, right there, because x is 2y minus 10. So 2 times 5 minus 10. Now, 2 times 5 is 10. 10 minus 10 is 0. So my coordinates for that one, 0, 5, using substitution. Okay, now these two, 8, 9, you get to pick. Okay, you get to pick which way you want to go. I'm going to do, number 8, I'm going to do substitution because of that y right there. So I'm going to move that 3x over. I'm going to say that's negative 3x plus 16. And I'm going to substitute it right smack into the other equation where the y is. So I'm saying 2x minus 3 times negative 3x plus 16 is 7. I'm going to distribute the negative 3 like that. That gives me 11x minus 48 is 7. Let's move that 48 over. It becomes plus 48. 48 plus 7 is 55. Divided by 11. There's my 5 for x. Plug it back in where we started. That would give me negative 3 times 5, which is negative 15 plus 16, which is 1. So my answer is x is 5 and y is 1. And number 9, hopefully the last one of these. This is a lot of systems, which if you're good at them, that means it's a great test. So I'm going to make my y's go away because I got a 1 and a 2. The signs are already different, so I'm going to multiply the bottom equation, which you can do, first time I've done it today, by 2. So 2 times negative 3 is negative 6. 2 times y is 2y. And 2 times 7 is negative 14. Now this, something weird's going to happen here too. Everything cancels over there. That's a 0. Over here I've got 1. So you could ask yourself, does 0 equal 1? Hopefully you say no. And because it's no, that means there is no solution. Number 9. Number 10, solve this system of using matrices and your calculator. This is RF. Okay. And we'll hopefully you got all the steps in class. I'm going to talk you through as I'm doing them right now. I'm going to second matrix, edit. I need a 3x4 matrix, and I'm punching in the numbers 1, 2. Now the first equation has no z, so I'm going to put 0 for that z spot, and 5. Then I'm going 3, negative 1, 4, 5, negative 4, 2, negative 3, negative 3. Then I'm going to second quit to save my matrix. Second matrix again. Go to math. Scroll up till you find RF. It's going to say RF with the parentheses. Go back to matrix. Tell it matrix A. Hit enter. And I'm looking for my last column. My last column says 1, 2, 1. That's the solution. Pretty cool. All right, number 11. Given the function, this is review. Identify. First of all, it's got absolute value, so it's called the absolute value function. Not too hard there. Graph the function and its parent. If you just graph the function, that's okay. There's a minus 3 inside. Just remember, shifts your graph left to right opposite of what you think. Because it's minus 3, I'm going to go right 3. There's really a 1 in the front there, the absolute value, so I'm going over 1, up 1. I'm going to draw my V, just like that. So there's the answer to part B. Describe the transformation. All you got to put is shifts right 3. That's good enough. Last one, number 12, is piecewise. Just got to look where you're going to plug them in. This one says F negative 3. Negative 3 is less than negative 1, so I'm going to plug it in right there for that x. So it's going to be 5 times negative 3 minus 2. That's negative 17. There's the first one. Then it says plug in negative 1. Negative 1 is equal to negative 1, So I'm going to do 2 times. I'm plugging it in right there. 2 times -1 is -2. Now it says plug in 0. 0 is bigger than -1. So I'm going 2 times 0, which is 0. And the last one, f of 7. 7 is also bigger than -1. So I'm plugging in the bottom one. 2 times 7 is 14. You should just get one number answers there. Some of y'all last week put some very strange looking answers for the piecewise. Hopefully that helps. Study hard. You got a good chance to do great tomorrow, I believe. I think you will do great, and I will see you then.